It's time now for a lightning talk by one of our SODA members. We have with us Yusuf Yildiz, a solutions architect at Linbit. He's also a member of the SODA TOC, and he's going to be speaking on storage management is more than CSI driver, how to solve issues with persistent volumes. Over to you, Yusuf.
Thank you, Anvit. Let me start with presenting myself first, because which is the most important thing here, right? So my name is Yusuf, and I have been in a professional life since 15 years now. And from starting as a system admin to solution architect, I worked in many positions. And currently, I'm working as a solution architect in Linbit, as Anvit mentioned, and also I'm the TOC member of SODA. So in this presentation, I would like to explain to you the Linstor and the Linstor storage management and these kind of things. All right, so who we are, what is Linstor, right? So Linstor is a software-defined storage with a 20 years of storage pioneer behind it, which is Linbit. And it has a strong replication component in its infrastructure, what we call this DRBD. And DRBD and Linstor recently broke the world record and managed to produce 14.8 million IOPS in a cluster. And Linstor and DRBD is DRBD is in official coding in Linux kernel since 2009, and we are one of the leaders in high availability, disaster recovery, and software-defined storage area. And Linstor is the fruit of this 20 years of block storage experience. And now let me explain to you what is Linstor, right? So a Linstor is a software-defined storage which has two components. The first component is Linstor controller. The second one is the Linstor satellite. Basically, you have to install the Linstor satellite on each worker node within your Kubernetes. And you have to install the Linstor controller in somewhere else. It can be in a pod, it can be in somewhere else, but it has to present in a place. And it produce the replicated volumes, the persistent volumes that you're looking for in your Kubernetes or in your OpenNebula, Proxmox, and many other infrastructure. So it has a in-kernel data path, which I just told you, which is the DRBD. And DRBD is like really low on resource consumption, and it is saving you the CPU and memory resources on replication and the storage I/O operations. And it has the minimal latency for block I/O operations, so you will have like really high performance cluster within your infrastructure. And what we did while building Linstor is we build on existing Linux components, so you don't get really confused about managing it. So you can use like DRBD, LVM, ZFS, Lux, video, whatever you want, whatever feature you want with the Linstor is possible. You just need to open up a CLI and make your changes with the respective storage pool, resource group, or resource itself. And Linstor is not in the data path, so that helps us to fix many issues like Day2 operations, because you know when a software-defined storage sits in the data path, that means you can't just do upgrades, downgrades, or migrate those storage components easily. But Linstor is not doing that, so you can easily migrate, upgrade the packages within the Linstor. It's whenever you want. And it is suitable for hyperconverts. It is suitable for the container environment because you can put like data locality in it. And it reduced the network loads and reads, and it reduced the latencies in your infrastructure, and so on and so on. There are many things that I can mention here, but since we have tight time, so I have to move on to my next slide. All right, so what is the issue with the Kubernetes and in the container world? What is the issue with the storage, the persistent volumes? So by default, I mean, the storage container architecture is built for ephemeral. And then the CSI driver, which was developed for the container storage needs, cannot take the whole load on its own, right? And you have a number of needs for stateless and stateful applications, and then you need them to be met by your storage layer. And this is where the most important component, the storage, comes into the play. In Linbit, we added number of new features into the Linstor by thinking about these issues and examining the request from our customers. So we managed to overcome many issues, such as, for instance, like install and implementation issues. So we all know that Kubernetes in the container world is great, but it's hard to install an implementation. So I can easily create a Kubernetes cluster, but adding a storage into it might be a little bit tricky. So that's why we created Linstor operator. With the Linstor operator, you can easily deploy the Linstor into your existing Kubernetes cluster, and that gives you the time so you can play with your kids. So you don't mess your time with like figuring out which is where. And Linstor also has this Stork plugin in it, and Stork allows users to. Stork is an open source project, by the way, and allows users to co-locate pods with their data. And that provides the seamless migration of pods in case, I don't know, storage errors, or and it makes it easier to create a restore snapshots of Linstor and so on. So it's a great value in added in Linstor for data locality and many more. So you don't want to reach your data from long distance if you want it. And the Linstor HA is here that we developed within the company, because the pod failovers took almost 90 seconds in most of the cases. So we built this component in the Kubernetes and the container management. And when a worker node fails for some reason, Linstor HA comes into the picture, and the fail pods is restored in under 15 seconds. So it's greatly decreasing the failover time within the pods. Of course, we also have this the YAML files that we want to make the deployment easy for everyone. And you will no longer have to add so many parameters into the command line. You can just deploy a YAML file, and the deployment will be easy for you. And last one is the kubectl plugin for Linstor, which is making easier to manage your Linstor cluster from the kubectl. Normally, you should have to jump into the SSH and log into the respective controller to manage, or the client to manage the Linstor. And with the kubectl plugin, you can just do like kubectl, Linstor, and so on and so on. You don't have to spend so much time in it. All right, so since we fixed all the problems with containers in like 5 or 6 minutes, and I also want to tell you guys that we are not just a container storage. Linstor is an eco project for SODA, by the way, and the eco project is a part of SODA, and we have many connectors to the different operators, such as OpenStack, OpenNebula, Proxmox, I don't know, Zen, Apache CloudStack, which is relatively new, and also Nomad from HashiCorp, which is relatively new. So we have these connectors to many operators, and Linstor is a great tool, great software-defined storage for fixing many issues in once. And thank you. And this was the end of my slide. I hope I didn't exceed my time. I can't hear you, Anvit, sorry. No, still can't. In the meantime, if you guys have any questions, I would love to answer that in the Q&A.
How am I doing on sound now?
Yes, it's great now. It's great now.
Okay. Thank you, Yusuf. I believe you were bang on time. It was correctly timed. And do we have any questions for Yusuf? I believe the whole discussion today has been from data and storage, and then we moved on to the cloud native world and container storage, and then how we will interact among all of these platforms together. So we're actually coming into a culmination of all of them together now. So I'm expecting some more questions. If not, in that case, we will be taking the questions for you later, and we will be answering them via emails. Thank you once again, Yusuf. It's been a great pleasure.
You're welcome. Anytime, Abid. It was always a pleasure to work with you in these sessions.
Awesome. That's great to know. And you have a great day. And with that, we will now move on to the next session. And that is going to be on... I'm sorry, yeah. So the next session is on COSI, C-O-S-I, the Container Object Storage Interface. And we have Nicholas Stranges, Principal Architect Scality, and Vianney Rancurel, Head of Research at Scality. Let's join in the next session. Thank you.
Thank you. Goodbye.